Okay. All right. We got serious glare issue, but that's okay. Okay. So yeah, we got matter. There's two types of matter, and that's about it. There's mixtures. We'll talk about in a minute. Pure substances is another type. All substances have uniform composition. There's two types of substances: elements and compounds. Elements are the simplest form of matter, so they make up all matter. Right? Have you heard the bad joke about atoms? You can't trust an atom because they make everything up.
That's terrible.
It is terrible. It's funny. In a terrible way. Atoms literally make everything up that we see and interact with. Atoms are pure substances because the simplest form of an element is an atom. So atoms are elements, or elements are atoms, kind of vice versa. And that's the simplest form. Literally everything is made of atoms and elements. So another phrase is they're the building blocks of matter. They make all of matter. That's another way to say it. Since they are the simplest form of matter, they cannot be broken down. Oops. Cannot be broken down. There's nothing simpler. Cannot be broken down. Elements. So kids say, okay, wait a second. If you take an atom and put it in a particle accelerator, which speeds up little particles like protons and smash it into the atoms like bowling balls into bowling pins, the atom will explode. So you can take an atom of an element and you can break it down. So I'm writing cannot be broken down. Here's the stipulation. If you smash an element and it breaks apart, and you have your protons, electrons, neutrons flying all over the place, it's no longer considered matter, it's considered energy. So this is still true. You cannot break down elements and still have a form of matter left over. You can break down elements and get energy from it. That's what nuclear chemistry does. All right, so we're still going to write this, but it's kind of like in quotes, broken down. Because you can, but it's no longer matter. All right, so anyways, I'm not trying to confuse you. I'm just trying to give you all the information here. So as far as the regents is concerned, you cannot break elements down, but you can break these down. We'll talk about that in a second. So, simplest form of matter, make up all matter, cannot be broken down. All atoms are identical. In other words, if every single person, let's say these red magnets were atoms of copper, and I gave each one of you an atom of copper, all of your atoms would be identical. So if we have a sample of copper, like a sheet of copper, and if I was somehow able to cut little atoms out and give them to all of us, all our atoms would be identical because they're all copper. They all have 29, right? Yep, 29 protons. Because elements all have their unique atomic number, that's true. So all atoms of one element are identical. Hopefully that makes sense. Questions so far? Okay, so simplest form of matter, make up all matter, cannot be broken down. All atoms are, some of this I have to look up here. Okay, yeah, that's it. So all atoms are identical. Maybe I feel like I should write all atoms have the same protons. All atoms have same number of protons. I know I'm getting messy here, probably too small to read. Sorry about that. All atoms have same number of protons. So the atomic number is the same for every atom of every element of the same element, right? So if Kara has silver and Amanda has gold, then obviously it's two different elements, so those two are different, right? We're talking about one sample of one element, all that's true. Okay, compounds. Why can you break a compound down but not an element? Right, so think of it this way. I really like to use these things. This is an element, which is an atom. This is an element, which is an atom. You can't break this down into another circle or another element or atom because it is as simple as it gets. But if you put two together, you can break this down by just doing that. That's just an analogy. In real life, it's not that easy. You can break them down, but it has to be done chemically. If you put it together chemically, you take it apart chemically, like decomposition. So can be broken down chemically. You can't physically separate compounds. I can't take water, so there's water vapor in the air. I can't take a really sharp knife and slice the air, and hydrogen and oxygen gas pop out. Okay, you can't separate water with a knife. That's crazy. All right, you can't break apart salt. You can't get sodium and chlorine gas. It's got to be done chemically. That's called decomposition. All right, so it should make sense that if you're taking elements and putting them together chemically, you can take it apart chemically, so these can be broken down, but these can't, right? So this is the simplest as it gets. So if you take two simple things here, put it together, it's more complex, you can break it apart back into its simple parts. I mean, it's not that easy. It's hard to do this, but it can be done, all right? So compounds also, just like over here, all the molecules, so these are called, why are these called molecules? That's an atom, that's an atom. Why is that called a molecule? What is a molecule?
A molecule is two atoms together.
Yeah, it's two atoms, two or more. It could be three, it could be more than two, but two atoms chemically combined. So let's put this. All molecules are identical. Just like an element, right? So an element, all the atoms are identical. Compound, all the molecules. So think of sugar. So you have a whole jar full of sugar, and then you were to break that down into one tiny molecule of sugar, which you couldn't see, but if you could, and you could feel it and taste it, it would have all the same properties of that jar. That's what that means. All molecules are identical. Okay, let's see. Okay, let's stop there for now. There's a little bit more about this we're going to talk about. There's two types of mixtures. If you looked at the homework, you guys have room in your notes to take notes? I'm kind of like creeping over here. You got room? We got some stuff to write. If not, I guess you can figure it out. Okay, it's two types of mixtures.
Are they like homologous and homogeneous?
Yep. Homogeneous or homogeneous. Homogeneous and heterogeneous. Okay. I guess we'll leave that going. Write those words down and come on back.